Hi, I'm Karl Gutwin from the University of Saskatchewan. I'm going to tell you about some work that was done with one of my students, Kim Kargut, and with Andy Cockburn from the University of Canterbury in New Zealand. So, the main point of this talk is whether or not it's better to remember things when you're in an immersive environment like VR. And the reason this has come up is because there have been a lot of articles in the popular press recently about working in VR. And people like Mark Zuckerberg have suggested that this is the future of work, that we will all someday be doing all of our regular everyday office work in places like the metaverse. And not just meetings, but all kinds of applications can be added into a virtual environment. And there are already lots of applications that will allow you to set up and use applications like Microsoft Office in your VR environment. You can set up different windows all around you in the virtual space. And you can even wrap the interface around you so that you're inside Microsoft PowerPoint or Word or Excel. And one of the reasons why people suggest that this might be a good idea is that there are potential benefits to being immersed in the data and immersed in the user interface. One of these is what we'll call the immersion hypothesis, that if you're more immersed in an environment, it will be easier for you to remember where things are, and then easier for you to get back to them when you need them. And there are some good reasons to believe in the immersion hypothesis. We live our whole lives in 3D, and we're very good at remembering where things are in those spaces. So if you put up a picture above your stairs in your home, you're naturally going to remember where it is because you live there. In fact, this idea of the memorability of 3D environments is actually the basis of a famous technique called the memory palace. This has been in use since classical times. And the idea is that you imagine moving through an environment and you mentally attach things to different locations in that environment, and then the 3D aspects of the environment help you to remember where things are. So immersion within the space of an application could be a good way to improve spatial memory for locations of data or UI elements. And this is what we set out to test. We manipulated two factors in our study: how the information was organized around the user, and then what kind of input and output devices, more or less immersive, were being used. So let's look at layout first. We built a simple 3D environment that could be arranged in different ways to change the level of immersion. This is the wrap condition, where the objects are laid out all around you and you're in the middle of the room. Here the objects are all on a flat plane in front of you, but you have to move left and right to see everything. And here the objects are also on a plane, but now you've moved back to the point where you can see everything all at once, at the cost of everything being quite a bit smaller. Then our second factor was the type of input and output. And we compared immersive devices, so a head-mounted display with handheld controllers, where the headset is tracked so that you can look around you and you can also turn around in the chair to see things behind you, with a standard monitor and mouse set up at desktop workstation. And this is obviously the less immersive of the devices. So here are the three names that I'll use for the layouts: wrap, flat far, and flat near. And for the two devices, we'll call those HMD for a head-mounted display and desktop. And we got people to carry out simple retrieval tasks, basically finding icons in environment and then re-finding them. And we measured how long it took people to find things that when they were normally visible. And then at certain points, we covered up the icons and people had to click where they thought the correct icon was to see how well they'd learned the locations. So I'll show you now what the retrieval tasks looked like in each of the different layout conditions. In these diagrams, the blue lines indicate the walls of the environment where we put the icons. The yellow triangle is the amount that the user, who's represented by the blue dot, can see. And the gray arrows show you how the user could move within the environment. So here's a video of the wrap layout. The icon to find was always shown at the bottom of all of the walls, and you had to click on the correct icon when you found it. There were 4 icon targets, and you did these over and over again in a series of blocks. And then after 3 blocks with the icons shown, we blanked the icons or covered them up, and you had to take your best guess as to where the icon, the correct location of the icon was. And then after the memory test, we turned the icons back on and continued with another set of trials. So here's the memory test where the icons are covered up, and you have to you take one click to determine or to take your best guess as to where that correct icon is, and then you go back to the regular trials. This is the flat near layout. You had about the same field of view as in RAP, but now you move back and forth in order to see everything instead of turning around. And here's what the tasks look like as we scroll back and forth. And again, the block series order was exactly the same, 3 blocks of visible trials, and then a block of memory trials, and then the whole thing was repeated. And here's flat far. You're far back enough that you can see everything, and so you didn't need to move at all. And here's what it looked like in the video, and you'll notice that there's very little movement here except for the mouse. And interestingly, although this is built as a 3D environment, flat far is basically what you would get in a normal application running on a monitor. You can see the whole interface without having to turn your head or scroll, and everything is a little bit smaller. I will show you one video of what it was like in the HMD, but I should note that the field of view here is quite a bit narrower than in the actual system, because when we took video from the headset, it only gets the view from one eye rather than from both. But this shows you these 2 lines, and these are the rays emanating from the 2 controllers. So users could point at and select any of the icons with either hand. Okay, so let's find out what happened. The idea is, does immersion improve performance, either in terms of retrieval time or spatial memory in terms of retrieval accuracy? So we also measured people's subjective sense of immersion, and the idea there was to make sure that the things we thought were increasing immersiveness really were. And we also asked people for their preferences after they've worked with both layouts, or all the layouts on both devices. So let's start with retrieval when the icons were visible. And this chart shows the desktop environment in red and the HMD in pink, and the 3 layouts are shown on the x-axis. So this chart basically shows how fast each of the combinations was. And there are a couple of important things to focus on here. First, look at how much faster the flat far layout was than the RAP layout for both the desktop and the HMD conditions. So this is the time per selection, and it's a full second faster to select things when you can see everything in front of you. And by far the best performing condition was flat far in the desktop layout, which interestingly enough is basically what we have now when we use a regular application on a regular monitor. But of course, the immersion hypothesis isn't really about retrieval time, it's about spatial memory. And so let's look at how accurate people's memories were for the icon locations, which we tested by forcing them to click on a location after the icons were hidden. And so the effects of immersion were actually nothing special. All of the conditions had about 90% accuracy, regardless of whether you used RAP or flat near or flat far, and regardless of whether people used the desktop or HMD input and output devices. So there are some minor differences here. HMD was a little better for RAP and a little worse for the 2 flat conditions, but none of these differences were significant, and overall everything was pretty much the same. So the results of our main measure suggest that there isn't a large benefit for spatial memory of being more immersed in the data. And remember that there's definitely a performance cost. With RAP layout and the HMD were substantially slower than just showing everything on a 2D plane. So this seems kind of definitive. We shouldn't put Microsoft Word in VR, at least in terms of whether or not we're going to be able to remember things. But there are still a couple of other measures that I'd like to take you through. The first one was just to double check that our immersive conditions really felt more immersive, and this was definitely true. For example, the HMD felt more like being there, people felt more present, and the environment felt more real. But the really interesting one is people's preferences. Here are their preferences for the device. And other than recognizing that the desktop was faster, people were strongly in favor of the HMD. They enjoyed it most. They thought it made it easier to remember the locations, even though that wasn't true at all based on the data, and they preferred it overall. We then asked people which layout they liked best for each of the device environments. Here's what they said about the HMD. Again, even though they recognized that flat far was faster, they strongly preferred the RAP layout. And again, they thought that it made learning easier, which was not true. Here are their preferences for the desktop environment. And finally, we see some results that line up with the performance data, in that people felt that the flat far layout was best on the desktop. And so, in summary, across 2 different device environments and 3 different layouts, we feel that you should be cautious about moving everyday applications to VR. The increased immersion did not lead to improved spatial learning. There were definite performance costs for the more immersive environments, and the best performing condition approximated a standard desktop setup. However, there were strong preferences for the more immersive conditions. And so this, although this might have been a novelty effect, this definitely requires more study. But overall, we don't think that people should be rushing to do all of our everyday work in VR. The desktop environment that we already have seems to be pretty good as it is. Thanks very much.